The last thing we need to address with limits is looking at limits graphically or looking at piecewise limits. And the most important thing for these two concepts is that the limit from the left must equal the limit from the right in order to say that the limit exists. And the way we notate this is instead of just the limit as x approaches c, we have x approaches c and we put that little negative there that you read it as from the left. And this one would be as x approaches c from the right. So in the little picture I have at the top, as I move from the left and from the right, I end up at the same spot. And so even though that exact point does not exist, we would say the limit exists. So let's look at some examples. In number 1, if I go from the left and from the right, meeting at C, I end up at the same place, so we would say that yes, that limit exists. In number 2, however, as I approach C from the left, we're going to positive infinity, and as I approach C from the right, we go down to negative infinity, so we would say no, the limit does not exist. In number 3, as I approach from the left, I'm going towards this y value, and as I come from the right, I end up here, and since those aren't the same y value, we would say no, the limit does not exist. Which is different than example 4. From the left, I'm approaching there, and from the right, I'm approaching the same point. So even though f of c is way up here, that doesn't matter. We would still say that the limit does exist. So let's look at a few examples. So if I want to look at the limit as x approaches 3. So as we get to x equals 3, here's where x equals 3 is. As we come from the left and from the right, my y values get close to -2. So that limit would exist. It doesn't matter that, we're calling this g, sorry. G of 3 is 1. That doesn't matter. The limit is still going to be -2. The limit as x approaches 1, so let's clear all that up. The limit as x approaches 1, so 1 is right here, my x value. So from the left, I'm approaching a y value of -1, and from the right, I'm approaching a y value of 2, so we would say that that limit does not exist. And we'll look at those specific one-sided limits in a second. Okay, what do we have next? And I'm going row by row instead of column by column. So number 2, x approaches 0. So here's where x is 0. So from the left and from the right, we're both approaching a y value of -1. How about for as x, whoops, meant to change colors, as x approaches -3. So where's my x value of -3? Right here. So from the left, we're going up there, and from the right, we're also going up there, so that's a y value of 3. Once again, it doesn't matter that this point, my actual y value of g of -3 is 1. That doesn't matter. That does not have to be the same thing as my limit. We're talking about what it approaches. Okay, let's try blue. So this is a one-sided limit. This means right here from the left. So you read it as x approaches -2 from the left. -2. So here's my -2 from the left. So my y value from the left is getting really close to 0. How about x approaches 4? As x approaches 4. 1, 2, 3, 4. So there's my x value of 4. And so I'm approaching, what is that? -1, 2, 3. -4 from the left, but the right side is not existing. There's nothing. It's like, hello, nothing. So we would say that that limit does not exist. Last couple ones. Now we're going to do another sided limit that shows us why we said x the limit as x approaches 1 doesn't exist. So this we're going to do as x approaches 1 from the right. So as x approaches 1 from the right, that's going up to positive 2. Then x approaches 1 from the left is going to a y value of negative 1. So that's why in, I think it was like number 6 or 7, we said that the limit did not exist for as it goes to just 1. Okay, limit as x approaches 2. So x value of 2 is right here. So from the left, from the right, I'm going to the same place, which is 0. And my last one is as x approaches negative 2 from the right. Negative 2 is right here, and we're coming at it from the right-hand side, so that's giving me a y value of negative 1. Basically, you just want to make sure you're paying attention to if it's written like this, that is a negative, and this is saying from the right. So just kind of keeping track of where your negatives, positives are, and which ones are telling you direction. We could also be writing these kind of complicated graphs as functions. And so when we are doing functions, it's the same rule that in order for the limit to exist, it has to be the same thing from the left and from the right. But let's start with just finding a one-sided limit. So this says, find the limit as x approaches 3 from the left, where f of x is all that junk. So if we want 3 from the left, my x values are going to be smaller than 3. So what that means is I'm going to substitute in 3 into that top function. So 3 plus 2 over 2, so 5 over 2, or 2.5. So when it's a sided limit, you decide which of the two pieces of your function you're going to substitute it in for. If it's asking you just the limit of something like 1, what that means is I'm going to need to substitute that value into both pieces and ask, do they match? So let's kind of split that up. So I'm going to substitute it in my first function, 1 cubed plus 1, so 1 cubed is 1, plus 1 is 2. Then I need to do it from the right. So from the right, I just have 1 plus 1, which is 2. And since they match, we say the limit as x approaches 1 of f of x is 2, since they match up. So we'll do the same thing with the next problem. The limit as x approaches 5, so I need to substitute it into my first piece. So 5 plus 2, which would be 7. Now I need to substitute it into my second piece, so negative 5 plus 10 would be positive 5, and since these are not equal, we would say that the limit does not exist. The limit as x approaches 5 of f of x does not exist. That's it.